Hello, my name is Tammy Vincent, and I would like to share with you today some things that we are implementing at Williams Intermediate School in Pell City, Alabama. Our research has shown that we need to help our students with their conceptual understanding of fractions and number sense, and hopefully affect their sixth grade academic achievement scores positively. So the first thing I'd like to do is just introduce what led me to choose this as my topic. Fractions are not only a basis for advanced mathematics, but they're also very important in the real world. So kids need to really understand how to do that. Students enter our school at Williams and they have no concept or no conceptual understanding of fractions, and we want to provide that fractional understanding so that they have a ramp from their basic skills to advanced mathematics in high school and college. And then fractional reasoning, as I said earlier, is a universal skill that they need at home and in the workplace. So that's something that we want to make sure that we provide them opportunity to understand. Research shows that students who struggle with fractional skills in elementary school will also struggle in middle and high school. And then we need to find ways to engage students so that learning is fun and it comes to them more easily and not as hard as just the paper pencil methods that we have formerly been giving them. The context and the demographics of our study, we are looking at 5th and 6th graders. Williams is a 5th and 6th grade school. There's 678 total students. 341 of those are 5th graders and 337 of those are 6th graders. Now, something important to know about this study and on our implementing these processes is that all of these 5th grade students come from 4 different elementary schools. So they've been taught in totally different ways by different teachers in different schools, and now they're coming all together to our math department at Williams for 5th and 6th grade. And so we have to try to find what those students need and what ways they best learn their math. Our ethnicity breakdown is 81% Caucasian, with 14% African American, 3% Hispanic, and 1% Asian and multi-race. Our lunch breakdown is 50% free lunch, 45% paid lunch, and 5% reduced lunch. So that kind of gives you an idea of where we stand with socioeconomics and ethnic traits that we tend to look at when we're looking at our data. So connecting this to the literature that we researched, the National Mathematics Advisory Board named fraction learning as a high priority in early schooling, in elementary schooling. And so we want to be able to prevent some difficulties for them in high school. So with us being the middle school, we're getting them with not as much understanding as they need, but we're wanting to send them to high school with a good basis for understanding all of those fractional reasoning skills. Fractions are not only a basis for advanced mathematics, they're also important in the real world. That was part of our research. A strong foundation in fractions helps students succeed in mathematics. And fractional reason begins in elementary school, it progresses to middle school, and performance on standardized tests suggests that students have been taught using traditional algorithms and that they have not been allowed the opportunity to model and actually learn the true meaning and understanding behind those fractions. More connections to literature is that fraction magnitude understanding refers to students' understanding of fractions as numbers and their ability to order them, compare them, and actually place them on a number line. It's important that students understand that a fraction is a number. And then when students learn to make connections between multiple representations, they demonstrate deeper mathematical understanding and enhanced problem-solving abilities. Fractions have received focus because a developed understanding of fractions is needed for success in learning algebra. And student success in fractional reasoning can build a sense of self-concept that is proven to be related to positive mathematical achievement. So all of these things kind of go together. It gives you an idea that fractions are necessary through school and outside of school in the real world. Fractions are to be introduced in elementary school, but they're to be built on through middle and high school so that students have a conceptual understanding. And so we want to take what we know about this research and we want to implement plans to help our students leave us with a better understanding of fractions than they came to us with. Even though 5th grade is the last grade that you see any kind of fractional standards other than division of fractions, you see that in 6th grade, we want to be able to provide them with opportunities to be successful because it's so important to know those concepts to be able to do the higher maths. So step one, when we sat down to talk about what we wanted to do, we first had to identify the problem. And the problem is that students do not grasp the concepts associated with fractional reasoning before they come to us in middle school. They face difficulties in math that are compounded each year. If they don't learn it one year, it compounds the next year because all of these math skills just build upon one another. And students did not attain mastery for fractional reasoning standards on the Scantron benchmark test that we've given for the last 3 years. So the purpose of this study is to improve the 6th grade and the 5th grade math scores on the Scantron benchmark test, on their classroom math scores, and on the new Alabama State Standardized Test called the ACAP, which we have not given yet. Then we went into the part of step one that proves that we need to address this situation in our school comes from our Scantron data. And if you'll notice on the screen, there are a lot of 5th grade. I took the top 10 5th grade fractional standards from the Scantron data, and you see here that 0 up to 16 students out of 300 and something students in the 5th grade actually attained these or mastered these skills, where 340 down to 325 did not master or attain these skills. So this is just last year's 5th grade class, the scores from last year. I pulled the scores from the past 3 years, and every year looks basically the same. We're just not gaining any ground when they come to us in 5th grade and giving them opportunities to conceptually understand. So step two was to come up with a group of stakeholders that we could gather together and have a plan to get this program going. Our stakeholders involve our administrators, our teachers, it involves our parents, our students, and our community members. We want to make sure that each one of these stakeholders are involved and accountable for helping to implement these programs, because when everybody is on the same page and working together, the success rate will be higher. Step three is the actual task force that we brought together. We had one of our administrators on this task force. We had 3 6th grade math teachers, 3 5th grade math teachers, 2 parents, 2 students, and a local business owner in the community who is actually owns a construction business and is quite familiar with the needs of workers coming out of high school that need to know have fractional reasoning in that line of work. And we started out identifying our problems and trying to come up with solutions by asking the 5 whys. We just started with the problem: why do students not understand fractional reasoning? And when we answered that, we asked why again and why again until we came down to some solutions that might be helpful for our students. Then step 4 is the decision-making process. We had to talk about our limitations, and of course our limitations are the same as any other educator in America. Money is a limitation, lack of resources is a limitation, and time is always a limitation, not having enough time to do what we need to do. So our task force made a decision that we would come to a consensus over which solutions would best impact our students, and that it would be a consensus based on what is best for our students and not necessarily based on majority rules. So we had to make those kinds of decisions before we could continue with the process. Step 5 is the criteria that we chose to follow. We chose to look for solutions that were easy to implement, that were easy to modify or to scale up or down or be flexible with, and obviously solutions that will increase our Scantron scores, because that's ultimately what our goal is. And an interesting fact, according to the National Assessment of Education, the NAEP scores, it says that only 40% of fourth graders are proficient in the U.S. in mathematics. This declines to 33% in 8th grade and 25% in 12th grade. So that's proof there from that research that these problems are compounding each year to the point from 4th grade to 12th grade we're dropping from 40% proficiency to 25% proficiency, and that's why we need to do something. So step 6 is where we talked about solutions, and these are 3 possible solutions that we came up with. Number 1 is to use visual representations, especially number lines, because of that research that we looked at that said students need to understand that a fraction is a number on a number line, and we can use these visual representations and manipulatives to help students increase fractional reasoning and number sense. The second solution is to provide professional development for strategies to help students gain a better understanding of fractions. We can't expect our students or our teachers to know how to teach and introduce these solutions if we don't give them the training that is necessary to do that. Number 3 is to provide students with real-world experiences so they can draw from their prior knowledge. They can actually learn how to apply it in their world, and when you can do those things, then more learning takes place than when you're dealing with fiction. Step 7, our feedback. We sent out at the beginning of this school year, after we had our task force meeting in the summer, a Google survey to our committee members and a Google survey to our parents. The committee members agreed on the solutions that we talked about, that we need to have real-world examples, we need to use models to help with understanding, and we need time to gather those resources. The parents, it was very interesting the things that we got from the parents. First of all, 53% of 5th grade parents responded, and only 41% of 6th grade parents responded. So we felt that was a pretty good number, even though it was only about half of the parents, but it gave us some good data to go on. And they shared their perception of student needs in mathematics. They shared some real-world examples with us of ways that they use math in their homes and in their jobs. And then they were able to voice some concerns about math related to their students. And so we took what they said and what we had come up with to make a decision on the solutions that we wanted to implement. So what we decided to do as a task force committee is to, number 1, provide visual representation and manipulatives to use in solving mathematics, and number 2, to create tasks using real-world examples or scenarios. And if you put these 2 together, we're hoping that that will equal higher academic achievement in math. And so those are the 2 proposed solutions that we are beginning to implement this school year. The implementation process is going to be from August to May with this year's school 2021 students, and it's going to be implemented by both the 5th and the 6th grade math departments because we know that it's something that our students need. I know that's a lot of data to sort through, but we really want to see how they respond to these solutions. The evaluation process will mainly, our hardcore data will come from our Scantron benchmark test that we take 3 times every year, at the beginning of the year, at the middle of the school year, and at the end of the school year. These are the results from our students at the end of the 19-20 school year, and these are the end of the results. These are from the 18-19 school year. These are from the 19-20 school year. Now you've got to take into effect that COVID has hit and we did not get to take an end of the year benchmark assessment last year. So our numbers don't look a whole lot different even with that, but we were hoping last year to have a better success rate than we did, and we just weren't able to benchmark them to have that data. All right, so step 11 is making adjustments. Our plan is after the benchmark that's taken in April, we plan to we'll have a data meeting. We'll have a data meeting after every benchmark, but we will look at the data. We will make adjustments and modifications as necessary to help the students have a better understanding and to hopefully help them make better scores. and then we will make those modifications and adjustments so that we are ready to begin next school year from the very first day, so that we can help our students and they have an understanding. So those adjustments will be made. We will present a proposed solution for the next school year based on our solutions for this school year, and we'll present those to the administrators, and we will be able to continue to help our students, hopefully for years to come, with these solutions. My references are here stated. There's a lot of information that came for manipulatives and hands-on learning. There's a lot of research based on real-world examples, and these are some of the references that I used during my research. The IL, or Instructional Leader Standards, that were mastered were Standards 1 through 7, Planning for Continuous Improvement, Teaching and Learning, Human Resource Development, Diversity, Community and Stakeholder Relationships, Technology and Management of the Learning Organization. I want to thank you today for being here and allowing me to present our proposed solutions to you. We're hopeful that this plan will give us some good feedback, some good data that we can work with to help build our students' mathematical skills in the future. Thank you again.